Kia ora. This is a quick overview of what you need to learn for the exam for the 91390 standard. So there are the three modules you have to work through. If you look at the assessment specifications on the NCEA site, you get given these points. Don't worry about the first point. We haven't discussed it, so you won't know about it. The second point is just simply if you need the specific heat capacity of water, it's just saying it will be given, so you do not have to learn it off by heart. You are also going to be given from 2018 a resource booklet which contains the periodic table and these equations. N is equal to CV, N is equal to mass over molar mass, the calorimetry equation, as well as the Hess's law equation, where you've got the heats of formation only. So the final point is that all the symbols, etc., will be following the international conventions, and you can find out if you're not sure what they are. In this sheet, just Google it. This is what it looks like, but we have followed the conventions in the modules, so you should be used to them. Right, so these are the ones that are being given, so you don't have to learn them off by heart, but it is helpful if you're trying to work quickly through the exams, if you do know them off by heart, but you can always check by looking at the resource booklet. You also get told that you're expected to use molar masses. They can either be given or you must work them out from the given periodic table, and you must show all working. You must round off to the correct number of significant figures and include correct units. These last 2 points are for an excellence grade. Right, what do you need to know? The properties of particles, so it's the electron configurations first of all for the first 36 elements, so up to krypton. You need to learn the exceptions in copper and chromium. So remember that the copper has the 4s1 and 3d10. The chromium has the 4s1 and 3d5. So those are exceptions. Make sure you know them. Also remember for cations, especially for the transition metal elements, remember you take from the 4s before you take from the 3d. So those are key points to remember. And then also, as a check that you haven't made a silly error, just count your number of electrons, and that should equal the total number of electrons given as the atomic number in the periodic table. But remember, of course, if you've got a cation, if it's a positive charge, you subtract the number of electrons from the atomic number that's equal to that charge. You can also use the shorthand version, although here you can't check as easily whether you've got the right number of electrons, because unless you just look at the periodic table and say, right, neon has got 10 electrons, so 10 electrons plus the 2 plus the 5, you could get around it that way. Right. Next thing you need to know, periodic trends. So atomic radius, ionization energy, electronegativity, and you've got to compare atomic and ionic radii. Think of pens to explain the trends, so the number of protons, number of electrons, energy levels, the nuclear charge, the distance between the protons and the bonding electrons or the valence electrons, and shielding. Remember to explain those terms so that the examiner knows you've understood it. Don't just use it without explaining those terms. Also, if you're giving ionization energy equations, include your states. It's 1 atom or 1 mole of chlorine atoms in the gaseous state forming the cation in the gaseous state, because remember, we are removing an electron from in an ionization energy equation. Next things you need to know, Lewis structures and shapes, up to 6 electron pairs. So octahedral is your biggest amount, okay? And it's for molecules, polyatomic ions, so sulfate, phosphate, and so on can be included. And you can have with multiple bonds like carbon dioxide. And then you need to also be able to work out whether a substance is polar or non-polar. So for the Lewis structures, remember, work out the total number of valence electrons first. Okay, show your working, and then you're less likely to make a mistake. For the ions, remember to include the square brackets and the charges. That is really important. If you don't put them in, it's wrong. When you're discussing shapes, remember the regions of electron density around the central atom. So for carbon dioxide, you would say there are 2 regions of electron density around the central carbon atom, and these repel each other to the maximum extent, so there will be 180 degrees between them. So it'll be a linear molecule. So explain in that depth. Also, when you're talking about lone pairs or bonding, non-bonding pairs of electrons and bonding pairs, remember to say it's of electrons. Don't just say lone pairs or bonding pairs, because pairs of what? Okay, when you're talking about polarity of molecules and discussing that, try and practice a logical explanation and make sure you use your terms correctly. You should be able to discuss the electronegativity, that your carbon central atom and your oxygen have got 2 different electronegativities. So there's a difference in electronegativity. Therefore, there's a bond dipole. And in the case of carbon dioxide, because the electron density is evenly distributed around the central carbon atom, or you could say the molecule is symmetrical, those bond dipoles will cancel out, so there's no molecular dipole, and therefore it is a nonpolar molecule. Go to that depth, explain every point. You also need to know the attractive forces between the atoms, ions, and molecules, so you need to know about ionic bonding, covalent bonding, and the 3 different types of intermolecular forces. So it's the hydrogen bonding, the temporary dipole forces of attraction, and the permanent dipole forces of attraction. You can talk about London forces and so on as well, but these are the ones we use here in New Zealand. If you can't explain something in words, try diagrams. So a lot of students get tripped up by trying to explain what hydrogen bonding is, so the examiner is not clear, did you mean the covalent bond or did you actually mean the bond between the molecules? So draw 2 water molecules or whatever substance you're discussing, draw the hydrogen bond between them and label it, and that'll be perfect. Right. The final things are the properties of substances, so the melting point, boiling point, and so on. Remember, you've got to discuss all the forces of attraction when trying to explain why one boiling point is higher than the other, and discuss the polarity of the molecule as well. You could be given the boiling point, or you could be given it as in the terms of delta H vap, so be familiar with both. With entropy, you need to be able to state clearly that the entropy change must be positive for the reaction to be spontaneous. So the entropy change for the universe, which means you've got to think of the systems and the surroundings. And finally, the thermochemistry that we did in this module. Learn the definition so you know how to write a heat of combustion, the heat of formation, and so on and so forth. Is it 1 mole on the left-hand side of one substance, or is it 1 mole on the right-hand side of one substance, and so on? Then Hess's law, with your calculations, you either need the full Hess's law with all the equations, or you can use the shortened version if you are given the heats of formation only. And then there's the calorimetry. Don't forget the units. So the calorimetry is Q is equal to MC delta T. So all the best for your learning and exams. Goodbye.